we go. Hello and welcome to Flying High with Flutter. This is your host, Allenwyma. Today I'm with an extremely special guest. This is kind of like there's a father of Flutter, right? Would be Eric Siddell. And you're, I guess, kind of like the grandfather, right? One of the co-creators of Dart. So, Kasper Lund. So why don't you go ahead and kind of introduce yourself?
Well, yeah, great to be here. I'm Kasper. I'm sitting here in Denmark, and really excited about being part of the show here. And it's true, yeah, I did have my finger in Flutter very early on in relation to actually building out the Dart and the language underpinnings for Flutter. So great to be here.
Yeah, I found it quite interesting. I think I was telling you before the show that I tried doing some research about you, and I find you talk more about Flutter than you talk about Dart, which I thought was also interesting. But I mean, even your whole career is super fascinating to me, as we said before. Like what is your, first of all, let's kind of start like from your history, right? We talked about kind of the show would just be about your history and how everything kind of happened. So when you graduated high school, would you already know what you wanted to do, or what happened?
It was quite simple. Like early on, I got super fascinated with computers, and it started with like the Commodore 64s of the world, but quickly sort of grew into the PC area with 8286 AT and computers, and I got fascinated by the low level details of them. Like machine code programming was the natural next step for me after learning languages like Pascal and others, which was sort of great sort of entry points to the world of computing. So when I finished high school, it was fairly obvious to me that I wanted to do something with computers and something that was technical and interesting and challenging. So I decided to go to university and study computer science, and clearly that was just a blast. Great university here in Aarhus for computer science, and like the early courses on operating systems and programming languages and how it all sort of blends and fits together when done well just really fascinated me. So I think that really sort of pulled me maybe out of the more theoretical aspects of computer science and into the more like practically, let's build things, let's innovate at the low level and build fascinating technology for others to use in their work. So I quickly got drawn into that sort of practical sort of hacking style of building things in machine code and C. And I've loved it ever since.
Yeah, I'm kind of curious though. What was actually your first programming language? Because that's always interesting to hear. A lot of people, it's C. I think could be C, or is it something else?
It was actually BASIC back in the day. I went to the US as a 10-year-old kid, and at that point I didn't really speak English, but I did speak BASIC. So I was telling people around me in the US that when they asked me thing in English, I would reply to them, I don't speak English, I speak BASIC, and they didn't really get it. But that was the language that I sort of grew up on, and I learned that fairly well. And I think I get that from my father, who was also just interested in those aspects. So he taught me BASIC very early on.
So wait, you mean as a kid you were already a nerd when you said that kind of joke to somebody? Just I speak BASIC.
Yeah, I think that might be true. I learned the phrase from my father. If they ask you something you don't understand, you just tell them that you speak BASIC, not English. I think he thought that was pretty funny. I do now as well. I'm not sure I fully got it when I said it.
Well, it's a dad joke. It sounds like
that joke. Yeah, I know.
I remember when I was a kid, I used to tell my dad all the time, "I'm bored. I don't want to be here. I'm bored." He'd say, "Yeah, I'm nailed," and he hit me in the head with his fist. Obviously, not really hard, but
sure, yeah. So yeah, BASIC was the first thing, and then I got introduced to Pascal and Modular 2 and sort of high level languages, which I really enjoyed them, especially like the Turbo Pascal work. IDE, that whole area of having great tools for developing code in that really somehow also sort of piqued my interest in that sort of developer tool space. So yeah, I think I was in some ways fortunate or unfortunate, depending on how you see it, to be spoiled early on with some very inspirational tools and technologies around me. That was fun.
So when you're in school, like, was there any particular class that you really enjoyed? I guess
anything that was low level. Yeah, low level, like computer science. So courses around machine architecture, how computers work at the lowest level, how operating systems are put together, like how does a memory manager work, and things like that. I really sort of that really appealed to me. I think I liked operating systems more than languages at that point. I thought that this like writing code that sits underneath every other piece of functionality in the system was just like the most meaningful thing I could be spending my time on. So I spent so many hours on trying to get my PC to boot my own handwritten operating system. I mean, it didn't really do much, but it was just like fun times when like lots of nerds all over the world were connecting over the internet that was sort of like blooming at that point in time, and people were trying to write new alternative operating systems for probably for no good reason other than the challenge. It was fun. It's very easy to get your computer to triple fault and reboot spontaneously if you get this thing wrong. So like there's really poor help when you start from ground up, and you learn the hard way that planning well and being smart about how you work with your code is essential if you don't want to spend all your time debugging reboot loops.
I don't know. It sounds like if you like low-level code, maybe this was actually interesting to you, right? Just kind of trying to find the right situation which would cause the problem.
Yeah, no, definitely. It was fun.
Now, so I'm kind of curious about like how did you get into? Do you have a particular class about operating systems, and then that's what really got you into this kind of low levelness, or?
Yeah, we did have a class on that, and we also had a sort of a compiler construction course, which was also great. Like you get to build your own compiler for a new language that nobody heard of before, and just going through all that work to build a tool for, in this case, for pretty much no one, but still something that you felt proud of. Like having having the power over the machine at that level was tremendously interesting. I actually ended up, I think, through that to get a job at university, working as a student programmer on a sort of a very different, sort of more theoretical project in the space of colored Petri nets, which was sort of a modeling tool, and that was I think quite an interesting change for me. That was like high level coding in a I think to you probably unknown programming language called Beta, which was like developed here in Aarhus partly, and I really enjoyed that. Like some people were so into languages that they would invent their own and then get entire departments to sort of work and build stuff in that language, and that sort of made new languages not just something you would build, but also something that you could use for something that was of high value. And I thought that's super interesting. We did some crazy stuff like try to build low-level driver support in on top of Windows NT to make it possible to have two pointing devices like a mouse and a trackball attached to the computer at the same time, so you could do like two-handed input on your workstation, which was kind of novel at that point in time. Like it was well known for sort of graphical sort of high level like SGI kind of setups where people had experimented with the sort of dual input setups, but writing that in our own Beta language, having to write the drivers for Windows NT to make it all work, that was fun too. Like good challenges, but fun.
How would you even get to understand how to even make a driver? To me, I have no idea how to even start something like that.
It used to be a thing, right? So like back in the day, I think it was very common that you would come across a piece of hardware where there just wasn't a driver for the OS that you were using. I think people like maybe 15 years ago experimented with early versions of Linux. Probably also saw this, that you would get hardware that just didn't work. And like there are two approaches to solving that. One is I go online and look for the answer, and the other one is like build it yourself. And then I think we were just let's just plow through and see if we can build this thing and get something that enables us to do what we decided to try to do at the UI level, right? So didn't accept that as an obstacle. We just like did that, and Microsoft were really great at inviting us to come to like workshops to learn how to write these. So I have fond memories of spending time in Oxford learning about like the Windows NT driver model and how to build with that as a student. It was excellent times, I would say.
Well, I wish my school would have had something like this. That sounds super interesting. I feel like everybody else's school did way more interesting things, but it's just at least I know how to code. That's the important part, right? The problem is just getting the education to these kind of things. I was actually going to ask this is much later. Go ahead. Sorry.
I was just saying that in some ways that whole like working as a student programmer at university is also, I think, what really got me into virtual machines and working with language technology in a professional setting. A very good friend of mine, Lars Bach, moved back from the US, and he was the father of like Java hotspot technology. And he moved back with his family to Denmark, and I teamed up with him as a student there to work for Sun Microsystems, building Java implementation for cell phones when like cell phones and Java on embedded devices was still a very hot thing. So we built that for a couple of years here in Aarhus. So that was sort of my first sort of professional job for a real, in this case, American company building production ready virtual machines.
Well, let's kind of go back a little bit, right? So, yeah, so you took your classes, you really loved this low level stuff. So that kind of probably steered your direction in life about what you wanted to do, right?
Yeah, definitely.
And you also took a master's, I believe, right? And you don't have a PhD, but I believe you definitely have a master's. And that you just go straight to school after that, or did you work a little bit?
No, actually, I combined with working at university and later then at Sun Microsystems with the studying here. When you leave high school in Denmark and you go to university, it's like a five-year program that you enroll in the master's program, and then there's like there's a possibility of building a PhD on top of that, which is another 3 years. So you're setting yourself up for 8 years more in school if you go that route. And after those 5 years, when I was finishing the master's or deciding what to do in the master's thesis, I was more intrigued by getting out there building for sort of real world stuff than doing a PhD, even though my advisor tried to convince me to stick around and do a PhD. He felt like the area that I was interested in, again, like virtual machines for small devices, was interesting and novel enough that we could definitely research that a bit more, but I really just wanted to break out of that and write a master's thesis and form a company around the ideas in there and in the same setup, you could say.
Okay, so you graduate. You said you wanted to form a company, but you actually went straight to working at Sun, right?
I actually
Is
left
that right?
Sun to I worked only at Sun Microsystems as a student, and then when I was ready to finish the master studies, I left Sun Microsystems and started a company and finished my master's thesis in that context. So sort of a stage, slightly sort of interwoven studying while working kind of setup that worked really well for me. I don't think it works well for everyone, but for me that was really a nice thing. Um, I've always worked while in school. Initially, it was McDonald's. It was not super relevant for my work now, at least. But then at some point, I got the opportunity to work more in my field at school, and I think that was fantastic.
Oh, so you did actually have a somewhat normal job,
I
or
did, I
well, kind
did.
of typical job. I would have never imagined. I can. What was your job actually when you were at McDonald's?
I was really good at cleaning the tables in the lobby. I did that better than I expected, I think, and better than my parents expected too. So completely regular stuff. It was nice.
So your best job at McDonald's actually was cleaning. Cleaning the tables, you're saying.
It was very easy. So
For some reason, I can picture you flipping burgers, but not actually cleaning tables. But yeah, it does have to be done.
yeah, I did end up flipping burgers as well. Yeah,
But that was your favorite, was cleaning tables because it's just very easy.
it was
Okay.
just nice, and you got to work in a high pace, and people appreciated your work. It was very clear, right, that you were doing something for people, and I
Uh,
like that.
I'm just trying to think if I ever actually thanked somebody for cleaning their table at McDonald's. I don't
You really
think.
should. You really should.
I'm
Yeah.
not saying I shouldn't. It just never came to my mind. So that's
Next time you're at a good burger place or McDonald's, you should go and thank the lobby boy or girl, and be happy for their services. Yeah.
yeah. It depends on where you are. When I was in China, people just did the motion, but not really do anything. Hong Kong's a little bit better. U.S. You're lucky if the tables are clean. It depends on which McDonald's you're in. But okay. It's interesting. Any other kind of somewhat normal jobs that you had, or was it just at McDonald's and basically tech?
McDonald's, then programming. That's pretty much my career. Yeah.
Okay, so you are part of the statistic where everybody, was it like 1 in 5 or 4 out of 5 or something, that have worked in fast food?
That sounds about right to me. Yeah.
Okay, so you went to Sun. Now, how did you actually apply to get to this kind of position? Because I don't often hear, I mean, I know that there is this kind of workout, but how do you actually apply and get through the process? What was the process even like?
For at the Sun Microsystems, it was pretty straightforward. I think with Lars being in Denmark at university, working for Sun Microsystems there, I think he had the mandate to hire someone bright and energetic, and I was ready for that. So I think we just teamed up at that point. That was fairly straightforward. Like getting hired at Google is a completely different story, right? At that point, there was way more sort of classical interviewing happening and other things, but we're sort of getting ahead of ourselves a little bit here.
Yeah, I thought it's kind of interesting. Okay, so I mean, it depends on the company, right? Usually, I think bigger companies usually they have a different person who is kind of doing a lot of the hiring. Of course, you have to talk to your kind of direct at some point, but so he actually interviewed you, and was there any? What's it like to be interviewed by this guy? Was it like? I had one guy that was actually quite confrontational, right? And I think a lot of these research people can be quite confrontational. They like to argue, and my way of dealing with him was actually arguing back at him, and actually that brought some respect. So sorry if
Yeah,
I
no,
went for too long, but
I don't think I even realized I was getting interviewed. So he was sitting in the same part of the university as I was, and I was asking him about some technical things because he was a world-class engineer, and I just wanted to pick his brain on a few ideas, and we just spent some time together. And at some point, I essentially just had a sort of a job offer. Right? If you want to come work on these things with me, that'd be great. And I said, yes, of course, that sounds great. Let's do it. So it was sort of sort of a non-interview, if you will, over some weeks, right? Like the best way of doing it, if it's possible, right?
okay, so you're just chatting with him, and that was the interview. Was just you was kind of asking some questions about how does this work, or
Yeah, I think so. I don't think I even realized that we were having an interview. I mean, probably we weren't, right? But it sort of grew into that, so that worked well.
that's good. At least he
Yeah,
has an idea about. At least he
I
has
ended
an
up
idea about how your mind thinks, etc. Right?
yeah. I ended up working with Lars for 20 years, so I think that like, somehow we managed to find a to hit a good sort of working relationship right out of the gate after that sort of first few weeks there.
Okay, so he interviews you, then obviously you got an offer, you took it. And what was kind of the first thing you're working on? How was your first day like?
So we were starting, and this is what I really loved. We were starting building a new virtual machine for Java, targeted for cell phones from scratch, just the two of us. Like we quickly gained a few other people in the US, but it was like a small team with people that like Lars knew really really well. Sort of fantastic engineers all around, and then me as a student on the side building core parts of this thing outright with the help of the other guys. So really quickly, I started working on the interpreter for the Java bytecodes and making sure that they ran fast and implemented the correct semantics, and it's just getting in there, working on that, and making that all fit together was great. One of the early things I actually did there, and it sounds a bit weird to think of that. The first sort of professional thing I did in terms of programming for Sun Microsystems was actually build a small textual assembler where you could write in C++ code. You could write essentially function calls that would end up emitting assembly code for the x86. That's the starting point for our project. So we could build up essentially a assembly implemented like machine code instructions for the interpreter that we wanted to build, because we needed like full control of every single part of the interpreter. So we wanted to build that in like the lowest possible level of code there is, like the machine code level. But writing that directly by hand was annoying, so we decided to actually build a small generator for that in C++ code. Hotspot, where we got the inspiration for, also had this system, but they were doing like binary assembly instead, which like putting together the instructions in the binary form they need. We just found that for our purpose, it was just so much easier to just build the textual output and get a traditional assembler in play to do the final stage of translating that to machine code. That worked really well. So that's the first thing I put in. Does that even make sense? Like writing?
Yeah, I'm just trying to think about. So you actually kind of wrote like another bytecode or something that would also be translated into assembly. Is that the right way to say
Well,
that?
actually, we just wrote a small library in C++ that would allow us to get assembly code for the x86 emitted in a structured way. And with that in hand, we could write C++ code that would generate the interpreter for us. But it allows you to use C++ and all the structures in C++ to like share parts and do refactorings at that level. So it's much easier for us to control that. So it's just like a technique to get to build a fast interpreter really quickly. And I picked the technique up from the other parts of the team and from Lars, but that's the first things that I built. Yeah, it's been more than 20 years since I built that. It was fun.
It sounds fun. It sounds like something that's really up your alley.
It was exactly the kind of thing I wanted to do. Yeah.
Yeah. So you really kind of found the perfect first job for you. Well, second job, right? So
Yeah. There's very little machine code at McDonald's, but here there's plenty of opportunity to build this kind of thing.
now that you mentioned that, something came to mind recently. Is that did your milkshake machine always go down? Because I heard that there's a conspiracy about milkshake machines always going down.
But we did have challenges. One January 1st, there was actually a soda machine. Like people could not get Diet Coke at McDonald's where I worked, and that was dramatic. And people were like, almost crying, right? They just couldn't take it on January 1st after a rough night out, not being able to get your favorite beverage at McDonald's. It was a dreadful experience for all involved.
I'm surprised Diet Coke is the drink of the night out, right? I never would have thought about that.
Or maybe it wasn't. Maybe I'm forgetting. Yeah.
Yeah, but something. Yeah, I guess you need your sugar after you've been partying all night. Okay. You need to pick me up. A lot of people switch to soda instead of coffee, right? Okay, so after that project, what was your next thing? Was it straight working on Hotspot after that, or you had something in between?
We actually finished this virtual machine for cell phones, this Java virtual machine for cell phones for Sun Microsystems, and we shipped that. And that was like a couple of years spent on building it and getting it out. That was a lot of fun. But at that point in time, I was also getting to the end of my studies, and I had to pick something to spend the last year on, and something where I could get like a master's thesis out at the other end. So Lars and I, we had plenty of discussions about this in the past, that it would be fun to break out of a big American corporation and build a small startup instead, and build technology for embedded devices in that context, and get a master's thesis out as part of that. But essentially, like, go out on a limb and try to build technology in context of a startup company instead. So we did that in 2002. Again, virtual machine, lots of the same sort of technology space at least, but this time around for sort of embedded devices. And I think back in the day, like there were lots of interest in small chips and things, and we really thought that we could do the world a favor by making it easier to write code for a small embedded device than it was. Originally, Java was designed for that same kind of space with embedded devices, but it gained all of its success, at least initially, on the server side, and then when Android came along, it also got to you could say the modern client in terms of or in the shape of a phone. But we really thought that the idea of running high-level code on a small embedded device was neat, and something that we were very well positioned to deliver on. So we started a company around that idea. And I actually wrote my thesis there and gave it at least in Denmark, people are quite conservative with the titles of their thesis, and it's always like towards improving something. And we went all out and called it like revolutionizing embedded software. And and I remember that when we got the critique from the reviewers of the thesis, they were saying like, this is maybe a bit too much, and maybe it was. Yeah, I guess we didn't end up revolutionizing much, but it was a goal. Yeah.
Well, it seems to be, you always have to kind of overpromise in order to get kind of noticed, right? Nobody ever, you got to ruffle some feathers. Yeah. Actually, I kind of want to go back because maybe I missed something, but I remember talking about Hotspot, right? Now, the Hotspot, was that particularly related to mobile devices? Is that kind of what this was for? Because you're talking about how you're working on a lot with embedded and mobile, but to me, I thought Hotspot is always on the desktop. Maybe I missed something.
So Hotspot was a really good name. And a lot of the technology that was in the desktop and the server Hotspot ended up being useful in some shape in this mobile context. So the Java virtual machine we did was called the Java CLDC Hotspot implementation, and CLDC was a connected limited device configuration, I think. I mean, it's been 20 years, but I think that was the acronym. So it was like a hotspot implementation for a different class of devices, a different configuration of Java. And there, like, one obvious difference is just like the kind of APIs that are available and the kind of things you can do with that system are just more constrained, sort of boiled down and put in a different way. But at the core of it, right, it's a Java execution engine that needs to have a JIT and has to like have a garbage collector and has to have a fast interpreter. So all the things are sort of there, but they're just re-implemented, and they run typically on ARM chips or sort of the early chips that went into like the Nokia cell phones and phones like that back in the day. Feature phones, I guess you would call them today.
Well, that's what you'd call them back in the day. Nowadays, you call them what, the paperweights, I guess.
Cool,
Kind of
paperweights.
useless. Okay. So, all right. Now I understand a little bit more about why you said that. Okay. All right. All right. So you spent a lot. It seems like you kind of shipped the hotspot with the CLDC, I think you called it, and then you kind of were just like, all right, let's move on to our own thing, right? That was kind of what happened.
That's exactly right. We moved on, built new technology in a startup company. We actually sold the startup company to a Swiss company that was really interested in this Java and virtual machines for small devices space, and ended up working there for a couple of years on sort of device technology. So having gone through that experience of building up technology in a small team, then like getting acquired by a slightly bigger player and working in that context for a while, I still look back at that as a really like fun learning experience, right? That there's something really, really great about being able to start something small team, very focused, like going out there to try to really fundamentally improve how something difficult can be solved. And I think that's been a story that I've been fortunate enough to be involved in sort of playing out a few times over the years. So this like starting from scratch, build something with an idea of really fundamentally improving how well something can be done. It's been a big part of how I've gotten myself to be super motivated about working in the same field for 20 years.
Can you actually go back? So I think maybe I missed more about like what was your company's thing all about, right? You kind of talked about Java for small devices, but that's very broad, right? Maybe you can give a little bit more pitch about what exactly the problem you're trying to solve, and then how did you guys get acquired and why did you guys get acquired?
So I think it's I can get back to the story in even more detail a bit later, because I think there's a good segue to some things I'm working on right now. But at the core of it, right, we just realized that the way you would write software for small embedded devices was very much like a sort of a classical old school way of working with code. Right, you would write it and you would put it on the hardware as sort of firmware, and you would rarely update it if ever. At that point in time, you probably would never update it, and that meant that that code on the device was not really serviced in any way. It was just there, almost like an extension of the hardware, right? And the downside of that was really that the software quality was really hard to it was hard to predict everything that this thing needed to do after 2 years in production. So having it be unserviceable, not something you could deal with from the outside, was a big challenge we tried to solve. So our idea and the core context of of the thesis I wrote was really around enabling these devices to be serviced from the outside by giving them a small, in this case, not a Java-based virtual machine, but a Smalltalk-based virtual machine, which is another sort of old school, really elegant, object-oriented language that I remain very fond of. So instead of building Java virtual machines for cell phones at Sun Microsystems, we built Smalltalk virtual machines for embedded devices in our own startup company. But a lot of you could say the motivation for putting Java on a cell phone also applies to putting Smalltalk on a embedded device. It really allows you to change the code after the fact, manipulate the objects and the code in the system as it executes. And I think if you're familiar with Flutter and hot reloading, then maybe what I'm saying here is starting to sort of show you how some of this early work in that space, the serviceability, the ability to change code while the system keeps running and staying hot, is something that some people thought a lot about way earlier than Flutter. and something that we worked on very hard in this virtual machine for embedded devices space in the startup company. We call it OOVM. Very hard to pronounce, not the greatest company name, but it was short for object-oriented virtual machines. So our idea was really just to build all sorts of useful object-oriented virtual machines, starting with the Smalltalk version that we really liked. And we actually gave a demo where we had a sort of a small robot with an embedded device on it, where we could communicate with the device, and actually, while the robot kept running and controlling its motors and moving around, we could upgrade and change all the code on the device, introduce new fields and objects that were already created. I mean, essentially extend and fix the code while it was still live in there. So that's sort of this serviceability, this ability to change code, work with it, manipulate it from the outside while the system is running, was something we built in and put in the core support for very early on there.
That's quite cool. So, I guess you got noticed by this other company, and then they just said, "Hey, we
I think
stuff,"
so.
right?
I think two things happened. I think they noticed that. They're also I think getting ready for doing an IPO. So at that point in time, I think you're looking around to make sure that you have the right recognizable tech talent on your team as well. I think we fit very well in there, and also I think we offered a novelty to their portfolio that I think was good for them in terms of coming across as innovative, but also something that I think they really felt like could be the basis for future business growth for them. So I think that was like a great fit for us and a great fit for them. Sometimes it does happen. Yeah.
Yeah, especially you guys. So, I mean, you guys must be really famous now, right? You told me, okay, we came up with the hotspot, or we worked on it together, and then now we're working on this, and then that must have brought you some real credibility, right?
I think Lars, I think he was very recognized at that point in time too, right? He did fantastic work on the hotspot with the team there, and I think that was just really recognized. I'm fairly sure at that point, I think I was recognized as a super strong programmer as well. But I think having Lars as part of this was a major part of the reason why they were super attracted to getting us on board, and I completely understand why.
Okay, so you got acquired, you joined this company. I mean, how was it like the first day when you had to work at this company, and what was the process like?
Yeah, I mean, it was fairly straightforward. We had our own engineering office in essentially the same area as we've been in always. We were sitting at University of Aarhus, right across from where like Lars and I worked on Sun Microsystems Java implementations. So it felt like just being home, right? What we did get from the get-go was some really, really talented business folks on the side as well. Salespeople, people that care about business development that could come in and try to help us, put us in front of existing customers and potential new customers, and somehow that gave us a sort of an intro to the more commercial side. And I think we've always been a little bit stuck in the technology world, and that's sort of been our sort of our primary force, if you could say. So, but then getting into a company that also cared about getting this out there, getting this to the market, was super meaningful. They were in Switzerland and we were in Denmark, so clearly there is sort of a gap, but like the time zones work out well, and I think it worked. I think it worked pretty well for us there. Clearly, there's always challenges in going from like running your own shop to being part of something bigger, and I think that's probably a story you can hear from pretty much everyone who's gone through something similar.
But both you and him were at the top of the chain, right? And then once you were acquired, you kind of obviously weren't at the bottom, but you were somewhere in the middle. I mean, and then you're just like, oh, I have to actually answer to somebody about my own product, right? That must be a very enlightening experience, right?
Yeah, I mean, it is, right. But I think most companies, even if you run them yourself, you do end up sort of answering to either investors or customers, or I mean, it's very rare that you feel like you really have no dependencies. There's a start phase of any sort of technology project where you actually are very low on dependencies. People are not depending on you, and you're not really depending on them, and you can really focus and innovate. And it's really a time to treasure and really get the best out of. But it is sort of it's not something that can last, because I mean, I think if you stick in that mode for too long, right, you're sort of in the ivory tower building like for yourself. And even though that can be enjoyable, I think there's a limit on how far you can get with that, right? So it also has to get out there, and at some point you have to start like depending on others and allowing them to depend on you. But yeah, it was a change, but for me it's not a huge change. As long as you're sort of well aligned with what the top of the food chain here wants, it's straightforward. Clearly, when that is not the case anymore, if that changes, then yes, it's very different.
So when you got acquired, did you have to actually stick around for some time, or they
Of
said,
course,
you can?
oh no, that's the
Okay.
classical way of doing it, right? So you stick around for a while, and I think that the company at that point in time, like they were heavily into the Java space, and I think Java, it was sort of getting commoditized a little bit on some of these devices. So it was like something like all the cell phone manufacturers, they had Java, and there was like check mark. Yes, it was not used for that much on most of them. So it felt like it was a hard thing to guarantee it would continue to grow, and I think the company, Esmertech it was called, so I struggled a bit with that, sort of post acquiring us. I don't think we were to blame, but I think that turned out to be harder to monetize that well than they hoped for. And then once you're in a company where it starts getting more difficult to make money, being on the very innovative side of that is a challenging spot to be in. So after a couple of years there, it felt like the right thing to leave and look for a home that could allow for sort of more innovative work, pushing technology boundaries even more, right? And that was sort of 2006.
Okay, so when you guys, I mean, was it just you, or was it Lars, or was it you guys just kind of said like we need to go do something else together, or kind of what happened?
I think, I mean, usually what happens here when Lars and I work together, usually Lars will will sort of get the idea first, right? He'll say, it's now, and we have to act on this, right? It feels like we could be spending our time on something better. I'm gonna leave, and that felt very natural to me to say, that sounds good. I'm leaving too, right? But I'm fairly sure that it came from him, right? That it was. I mean, he felt like it was time, and I think he was completely right. So I think back in 2006, um, I was very much sort of following his lead on that, because he was just a tremendous capacity in the space, and someone I really wanted to continue working with, and I think he shared that perspective, right? So we decided that it was good time, and that we also had this idea that it should be possible to find something very interesting to work on within the space that we were already sort of completely immersed in.
Okay, yeah, okay, so it's time, right? So when it's time, like what's the process to find the next gig? Is it, that
We we
somebody's gonna come up to you, or sorry, go ahead.
we just left. I mean, we were four sort of early founders of the company. We all left at the same time there, and sort of that sort of gave us opportunities, and we were fairly sure. Because two of the founders in our small talk based startup company here had very strong networks in the Silicon Valley. So we were fairly convinced that it would be possible to get interest from some of these bigger US based tech companies. And it turned out that at least two of them were super excited about this, like VMware and Google. Um, it was not something that we knew would happen, but it was kind of hoping that if we gave it a few weeks, a few months, then maybe some new ideas, some new possibilities would pop up, and that turned out to be true.
So, so who was actually approaching you at this time? Was it, you said VMware was actually interested in you guys? Anybody else?
Yeah, Google. So I think Google. I think they really wanted Lars to come join them. So I think they when they learned that he was not employed, I think they were just super excited about it. So they asked him like, could that be something for you? And I think he thought that could be like a fun challenge. Like I think Google was growing out of just being a sort of a search company at that point in time. So I don't think Lars is a big database guy, but because of Google's involvement in lots of other sort of client side tooling and products, I think it was clear to Lars and to me that that there are things that would be fantastic to work on in context of Google too. And I mean, Google in 2006 had like, the best reputation, right, in terms of like tech company. I mean, it still has a great reputation in my circles. But at that point in time, it was sort of it was like the poster boy for Silicon Valley, at least from my seat here in Denmark.
And that, of course, at that time they also had the mantra of "Don't be evil," but I think they removed that recently, right? They said
I
still
don't
you still
know.
think they're not evil?
When I joined, they were definitely very keen on not being evil. I think that there. I mean, there are so many good people at Google. I think they do like truly care about what they're building, how they're getting it to the market, and all that stuff. But I think when you get really big, it's very hard to sort of be as clean as you could before, just because you have so much surface, right? I think the people that are working there are doing it and doing it for the right reasons, and they keep on pushing what you can do. I hope you just saw some of the announcements from Google I/O. It's quite impressive what's happening there. So it's very high on my list of fantastic companies.
Yeah, I'm kind of curious about how you feel. I mean, you start up with Dart, and Dart kind of is. I mean, so you're not. I don't think you're still working on Dart, and somebody else is taking over. I mean, that must feel a little bit. To me, I think that feels a little bit strange to kind of see somebody taking your ideas and kind of running forward with it. I can imagine that there could be some things that they're adding or removing, and you're like, no, don't do that, or I wouldn't do it like that, or
No, of course, right? But it's hard to argue with success. So I think they're doing very meaningful things with it. I think I'd much rather have that and actually see it grow and become a valuable tool for more people than have it stagnate and sit somewhere in some form that I thought was at least early on the best form. And then the team around it is still like super strong, motivated team that keep on pushing. And I think with Flutter in the mix, they have a real mission now to really change how mobile software can be built. And I think honestly, it's been really fun to watch and follow from the outside as well. I think it's moving along and getting to that point where it has that impact that we always dreamt of, which is fantastic to see.
I also thought it was kind of interesting when I was listening to. I think I listened to your podcast with JavaScript Jabber recently. I think a couple days ago, and I remember specifically you guys were talking about that people were asking for mix-ins. And then I start to think about, wait a minute, we have something similar called extensions, right? So that must have been something you were also working on before you left, right? Because that can't just be an overnight thing.
So most of I think the ideas that are being implemented in Dart are ideas that go back, right? And some of them were rejected early on because they felt like they were too complicated or didn't add enough value. And then I think as people start using a language, you also see it in different contexts. And the things that might not have been worthwhile doing early on suddenly has a lot of value in some contexts. There are other things that also change, you could say, the flavor of the language a little bit, turning it from being primarily a dynamically typed language with some optional typing on the side to being, I would say, a strongly typed language with some dynamic features. Also changes what are the most meaningful things to do to the language, I think. So I think that space and that just like going from essentially designing a language that is supposed to be a fantastic thing for building small things that scale up to understanding that we've hit something really good, but now we're seeing people struggle with code bases that are like a million lines of code or more inside Google. Suddenly, what's valuable in a language does change a little bit. The things that are fantastic for people that are just getting started, but in the way for people that are building millions of lines of code, may not be the right things to focus on anymore, right? So the balance shifts, and I think any living language sort of needs to be able to change with that a bit. I think that's one of the things I really like about language work today compared to 20 years ago. I think people are sort of more flexible in terms of their willingness to accept change. It can be hard, and like Python 3 was not necessarily a great rollout for a lot of people, and I think the stories around that are not ideal. But on the other hand, like they still did it, right? They still actually decided that changing, adapting, modernizing was worth it. And you can argue against that, but I think the mindset for the entire industry is a healthy one. Otherwise, the only thing that can happen is that you need to completely replace the language and start over, right? Which can be good, but sometimes it also sort of sets you back too much. So I think if we can find that balance, starting over every now and then, but also be willing to adapt, iterate, change, and even accept that the right decisions or the decisions that were right when you started out may not be right or completely right anymore. I think that's a very healthy attitude to have towards this, right? Because like we started Dart in 2010, and it is not surprising to me that 11 years later it's used in different contexts, and what's really, really truly important in Dart are probably the same things, but sort of around around the core of that, things will have changed a bit. Yeah. As you can tell,
I do want
about
to.
that. Yeah.
I do want to get more, of course, into Dart. But what I was thinking about was two things came to mind when you were speaking. One is that I was quite surprised about. I feel at least that Dart is moving extremely fast in terms of changes, right? Like sound null safety, now FFI, right, is even more in there. Quite a few other things, if what they call extensibilities or extensions. These are all quite a lot of, I would call rather big changes to the language. And it's amazing that somehow that the team has found out, okay, we can introduce new features, but at the same time, we're not going to rock the boat too much. And when we are rocking the boat, it's actually kind of it helps the boat move along, not just like us trying things and then we're doing the wrong thing. The other thing I wanted to mention too is that you're talking about like people nowadays being more receptive to changes, but like let's not forget. I think if I remember correctly, talked about Python 3. I think Guido kind of left Python kind of being on the side because of people being resistant to changes, or at least the changes that he wanted to put in.
It's not
I
a
think
solved
that's the
problem.
talk.
No, it's not a
Yeah.
solved problem, but I think the bell. I mean, lots of people don't like change, but I think there's enough momentum around the people in the world that see the value of iterating and changing, that the balance has shifted a little bit towards that. It's particularly around languages where it used to be more stagnant, perhaps. Look at a language like Java that like deliberately didn't change much for a long time. They're also now, I think, seeing the value of not getting left behind, and I think they're just completely changed their way of thinking of this and working with it, right? So they're also, at least seen from the outside, right, much more interested in pushing new changes, adapting, and working in that space, right? That will attract like top talent to working on the implementations because people want to build new things as well. I think generally it is a way of making things not just different but also better if done well. Yeah, clearly there are also examples of people getting it wrong, right, and messing a good thing.
Yeah, indeed, yeah. Sorry, I'm just actually still thinking about all the changes that Dart's been doing, and I'm still quite surprised that I haven't heard anybody actually ever complain. In fact, people are complaining that they can't move to null safety, actually, which is a bigger complaint, and I also wish that things were easier to get to null safety. Um, but yeah, in any case, sorry. So I actually kind of curious about like you went to, I mean, you went to Google or Google came to you, or to you and Lars, and then like because you said there's so many things that you guys could be working on. Like, how was the process that you could see? They just say, "Oh, what do you want to do? You want to do this? Okay, we got this project that could be interesting."
Um, I think Lars, as part of the sort of the discussions here, found that they're thinking about doing more on the browser side of things, and I think we saw that the browser was right in front of so many people in the desktop experience. So anything in that space, like trying to improve the browser as a platform for code for applications, was something that we both thought would be like super interesting, and that turned out to be exactly what we ended up working on. Right, the Chrome team had just been started, and like, what sits beneath the Chrome of the car? It's the V8 engine. So we thought that this is a very meaningful thing. It's a new team within Google, so people like everyone is building sort of from scratch here, and trying to put together a new product that we like. It's exactly our kind of thing, right? Build from scratch, put together a new product, and try to get it to the market, right? So that just felt like an obvious place and also an obvious use of the technologies and the know-how that we had, right? So can you make JavaScript run faster in the browser? Of course. Like we were just completely sure of that, right? We looked at it. It was very fragile. I mean, it was so easy to write code that would like get the browser to its knees, like infinite loops and whatnot. It would not tolerate that well. And also, just like if you started like throwing complex algorithms at it, it would just be so, as Lars would say, dog slow. It would just, I mean, just didn't feel like it had been optimized well. It hadn't been designed for robustness of performance, and it hadn't been optimized right. And we just thought that, hey, this is a great opportunity, right? And part of us probably thought that this is like ripe for change, and ready for us just getting in there and trying to engineer this the right way from ground up. So that's what we did. That was a ton of fun. No, it was great, right? No lines of code, starting from scratch, and the kind of thing that we built from the get-go, like an assembler that would allow us to build the first sort of the JIT for V8 from within the first like 2 weeks. So like back to square one, start over, right? It's great.
You're going to confuse a lot of people again, right? Talking about using Java methods for your JavaScript, because people always get confused between the two, right?
Yeah, no, it is confusing. You know how that story, like the reason why it's called JavaScript? I mean, it actually
My understanding was a marketing thing that they wanted to appeal to Java people. Yeah.
And I think I mean, right now it probably just leads to confusion, right? Which is unfortunate. But I agree with you. I think the story I also heard was a marketing thing, right? Some people wanted to benefit from the Java brand in this context as well, and sort of bring it into sort of align it with that. We came from Java, worked with Smalltalk, ended up writing a high performance JavaScript implementation for Google at this point in time, and at some point actually we started toying with a few other technologies inside. I stayed on the V8 team for a little bit longer than Lars, and I took sort of my first sort of lead role on the project there, writing the first sort of adaptive optimizing compiler for JavaScript, Crankshaft it was called, in 2010, and we actually put something sort of an old technique into this in this context, which is something that I don't think a lot of people realize how cool it is, and it has a weird name that most people don't think of as sort of one of the best ideas in making your programs run fast, and it's called de-optimization. And people think that must be a bad thing. Like, why is de-optimization a good thing? And it really is the support you can put into a system that allows you to back out of optimizations that turned out to be too optimistic or too aggressive. So with a de-optimization engine in your system, you have the opportunity to make bets. Say, I think the code is going to mostly follow this path or do this thing more often than this thing. If it turns out I'm wrong, we will de-optimize, go back to a more a slower and more primitive form. But we have this translation engine that allows it to get out of jail, get out of the too optimistic optimizations. But just having that part, this way of getting out, allows you to be much more aggressive. To say, I don't really know, but I think that people are going to call this method only on strings, not on anything else. So I'll optimize as if that's the case, and then I'll catch if they ever do something that's outside of what I optimized for, and then I'll just de-optimize. And then we put that into Crankshaft, like this V8 JIT on steroids from the get-go, because we thought we need something that enables that next like factor of 3 performance increase, and that just worked really well. And I think today most of the engines out there in the JavaScript space have this kind of thing built in. But that's kind of things I like to take something that sort of invented in a sort of more academic setting, bring it into a practical context, in this case, dynamically typed language like JavaScript, and get it out there, and that get others to get inspired and start building on some of the same ideas. So yeah, de-optimization has always been one of my favorite ways to make your code run faster, which sounds like counterintuitive, I guess.
Yeah, it's quite interesting. Kind of almost like machine learning or something to it. Or I was also starting to think about like doesn't the CPU also do something similar where they try to, but that's also how they get exploited, right?
Yeah, yes, that is true, right? So they generally call it speculation instead, but it's sort of the same kind of thing, and clearly they also need to get out of that. The problem that we saw a few years ago when they found that was exploitable was that it actually left traces when they did the speculative code execution. So you could tell if it tried to do that, and that was exploitable. I think if the optimization works correctly, if you will, the ideal is at least that you cannot tell if you went on a wrong path and got back again. Most things are just like security-wise extremely difficult today because of the realization that you can convey a lot of information through timing as well, and it's just kind of hard to control that. So, but yeah, it is certainly something that CPUs do as well, speculation, and then sort of somehow unwinding from that and executing as if they never did the speculation, right? It's part of that.
Okay, okay, that's pretty interesting. But I think the funny thing about like you actually maybe let me step back a little bit more. You said that I mean they had a Chrome team, right? So was there actually a Chrome beta out by then that people had, or was it just an internal project?
It was the it was a big secret. It was a big secret, even within the
Okay,
company. It's not something that we talked about. It was something that we felt like was worth preserving because we just knew that it would generate a lot of interest if we told the world. So when I joined, had our own team there, and we were working on the browser, and we weren't able to tell anyone that. Chrome got its start from essentially porting WebKit to Windows, and WebKit was or is the rendering engine for Safari, for the Mac. So they still had the old JavaScript engine in there from WebKit, and we just like essentially built a replacement for that with V8. And we made V8 something that you could use standalone as well from on the outside, which helped us build it, but also enabled something like Node.js to just pick V8 up without Chrome and put it into a server-side context, which was like awesome to see. I still remember when we had Ryan Dahl visiting us in the Aarhus office, the inventor and first implementer and hacker on Node.js. That was just a good experience too. So he was just able to get a high quality JavaScript engine, wrap it in a web server context, and get Node.js out really quickly. And I think he did a fantastic job on that. But this way of building it so it could replace the JavaScript engine in the browser that would be released as Chrome later, and then also make it available for others. I think that was a good decision we made there. But yeah, Chrome was an internal sort of secret, and we worked on that for a while before we started dogfooding it on the inside of the company, getting people to use it. And I remember it was a fun thing, and we had a dog food release out internally, and the first version where we enabled V8, we got ready to send out the new sort of internal release of this alpha version of Chrome, if you will, inside Google, and we sent it out with V8, and I think we were all just super impressed how much faster it was, like loading Gmail, everything just felt just much smooth. Turned out we forgot to enable V8 in that release, so it was all just like how we perceived it. I think we all wanted it to be great. In reality, at that point in time, lots of the web apps were not really pushing. They're so constrained by slower browsers like Internet Explorer that they just couldn't really push the functionality to the limit because they didn't have a fast execution engine. So most of them just didn't really have a lot of like meaty JavaScript to throw at our new engine there. So it made very little difference for existing apps at that point. That quickly changed once we got it out, right? Because then suddenly we had something that people could throw more at, and they wanted to throw more at it. And today, like JavaScript apps are huge and everywhere. But at that point, I still remember that sort of somewhat embarrassing moment when we realized that we shipped the new version where we thought V8 was enabled. We even celebrated, and it turned out it wasn't. So yeah, that's the way it goes.
So was there like a .1 kind of patch release that kind of got pushed down and said, sorry, try this one instead?
That was the next release internally, right? So when we were ready to release Chrome, sort of to the public, right? We had a cartoonist essentially write up technical information about the product and tell the story about like why and how we built Google Chrome, and that was part of the announcement, like getting that out, that cartoon, and I think you can still find it online. And I'm in it, and Lars is in it, and we were talking about how we did JavaScript and all that thing, and so that was fun to do. What Google in Silicon Valley didn't expect was that like the German postal services are very efficient. So they mailed the cartoon, like the physical copies of the cartoon, to tech people in the world, also in Germany. And the folks in Germany, I think it was in Germany, they got them at least a day earlier than they expected. So suddenly the whole internet knew about Google Chrome. It had not been announced. You could not download it, but they're all reading this cartoon about it. So we scrambled on the inside and made sure to get ready to release it really, really quickly. And I think it got out a few days later. But we had the whole internet, at least that's how it felt like for us, right? Talking about technical details of a product we built without being able to see it or try it. They still talked about the technical way we put it together. Maybe that was actually like the ideal way of launching a very sophisticated technical product. At least it worked really, really well for us, right? People were talking about how it was put together, how tabs were isolated from each other, how everything was built and for which reasons they were built. So like, we gave them nothing but that information, and they got excited about it.
I'm actually kind of curious about what is was ever released about like why they choose the name Chrome for the browser?
It's a good question. I'm not sure I have the official answer to that, but I think for a long time it was sort of a bit of a tongue-in-cheek kind of name for it, because the UI parts of some of these applications were known as Chrome. So I think if we were building looking at the internals of Firefox or some of the other things, some of the UI elements were referred to as Chrome. And the idea in the Chrome UI design was really to focus on content, not Chrome. So like the web page, not everything else that's floating around, not big title bars, not drop down menus everywhere, just like focus on content. So the tagline sort of for the design work was like content, not Chrome. So I think someone just thought would be fun to call the product Chrome, given that tagline, which was like ultra confusing, but still like it kind of worked, right? So I think that was the intent, right? So in some sense, it was intended to be designed completely opposite of its name, right? Focusing on web content, not everything else.
Yeah, I remember using it. I thought that was actually pretty cool. That like everything was really slim or slender right on top. The tabs are quite small, so that makes more sense now. But I find it quite interesting too. Like so, obviously, I mean, I don't want to take some of the shine away from you, but also the Chrome when it came out, it sounds like there was a lot more to it than just V8. Of course, V8 was it's pretty massive to what it came out of it, but still, Chrome itself, it sounds like it wouldn't even turn on V8 yet, and all of a sudden, everybody felt like everything was quicker, right?
Yeah.
So it's just
I think
you're
right.
just general improvements all the way around, right?
I think a lot of the things that people really fell in love with in Chrome early on was that the design, a really, really awesome URL bar, like a place to write your things with auto completions and suggestions and whatnot. That was fantastic as well. And then the fact that it was a really well done multi-threaded design that really made sure that there were very, very few places where you could feel the UI become unresponsive. It was very responsive all the way through. So and the team spent a ton of time on that, and that's part of the reason why Chrome felt so extremely quick, right? Focus was on quick startup, quick interactions, no unresponsiveness, just this feeling that you're in control and it's just there for you. I think that worked really, really well. And initially, V8 was more an enabler for what was to come than the reason why it was fast. But when you ship something and benchmarks demonstrate that some things run like 30 times faster than on competing browsers, people will give a lot of credit to that as well and think, oh, that's the reason why Chrome feels so fast. And that's probably unlikely to be the case, right? It's probably because it was so responsive and so fast to start. People fell in love with it. Like, I think today, right, V8 probably turned out to be more important than people thought, because it really enabled lots of innovative work to be done on top of it.
So actually, that's kind of interesting. I'm actually like kind of going back to V8, right? When you came out with V8, I mean, I can't imagine having a JavaScript interpreter that's actually outside of a browser because at that time we weren't really doing things like that, right? So why did you guys decide to kind of have it isolated?
It's actually for almost embarrassing reasons, right? We just Chrome as a project was a big project. So if you were to commit changes to the Chrome code base, whenever you were to commit a change to the system you worked on, you would be like potentially getting in the way of a lot of people. So we just wanted to decouple ourselves from that, right? Work on something where we could deal with the integration on a weekly basis, not every single on every single commit. So it's more like a way to make our engineering tasks and efforts more efficient. I think we also thought that maybe it could be useful outside the context of the browser, but like the primary reason was really just to decouple ourselves from that big engineering effort and say, okay, we will build something that's like a black box replacement for a chunk of your system, and then we'll roll it in there when time is right. So that gave us some benefits of the decoupling. We could go do our stuff on the side, but I once we like 3 months into the project and we were like 25 times faster than the competition. People got excited about it and wanted to see it integrated and be sort of more closely coupled to Chrome in there. So yeah, we just kept it outside just to make it easier for us to hack on it, essentially.
I'm also kind of curious too because I know I could install V8 by itself. Like, so was it that Chrome was released first and then V8, or V8 came out first, or they came out at the same time, and it was already decoupled as soon as it came out?
It was decoupled as soon as it came out. So yeah, and I think we open sourced on pretty much the same day.
And then from there on, you guys were when you open sourced everything, you must have just be committing everything in public, right?
Yeah, that was the model for it. We just worked up against the public repo. And I'm not sure we were not super sort of engaged in trying to get people from the outside to contribute initially. I think that's gotten a lot better. I think we felt like we had so many big things we had to accomplish in the Google setting that we focused exclusively on that. So I think it grew from being like, here's open source thing you can go look at, to being a real engine that others can at least think about contributing to and using over some years. But I think for us that the community part of the open sourcing never really like sort of made it to the top of the list. I think that's the honest version of it. We were so busy on trying to make it faster.
So the goal of V8 was actually just to be faster. Is that kind of the main goal, or was there any kind of like three main things or something like that?
I think faster, but also much more robust, right? I think we wanted something where we could see ourselves running really massive web applications on top of, and that really required the memory manager, the garbage collector, and all that stuff to really scale well to large applications too. And you can say that's a performance thing as well, but just making something that's very hard to make do the wrong thing, something that's robust against even massive applications that performs well at scale, was a big chunk of what we wanted to do. And we wanted to build something for non-toy apps, something for real massive applications. I remember putting in a limit on the amount of memory each instance of V8, each tab in your browser could use initially. And we put in 32 megabytes and thought that was plenty. Like no web app should use more than 32 megabytes of memory. And I'm sure that if you look at your browser today, you'll find you have tabs that use like a couple of gigabytes. So we had to change that limit at some point. But initially, that was just like way too much, even, right? But it's just like a different time, and also the kind of things you would throw at an engine like this, which is very, very different. Much simpler, much smaller, simple things, really.
So what's the secret of success for V8 in terms of like the optimizations to make it really that much faster?
I think that the biggest insight was that lots of applications, maybe less so than it was the case back in the day, but at that point, JavaScript was very dynamic, and you could do all sorts of weird things to it. But most code that actually ended up running on these in these browsers didn't do these things, right? So if you could optimize for the case where people were not adding new methods to their objects all the time while the program was running, and make it really fast in case they didn't. I mean, it's against this sort of de-optimization idea at play, right? And catch if they did and fix it, but still make sure that those sort of optimistic. Let's assume that people use this as a fairly simple language where like methods are where they need to be, and you can call them this way. I think that was the core insight. And once you look at it that way, you can put in some tricks and techniques that catches if people go outside of that. And if not, you can start using optimization tricks that are applicable from languages like Smalltalk and Java that are more well-defined, where people do not change the methods sort of on the fly as part of the program execution. So I think we just sort of pulled JavaScript out from this very dynamic thing. You can change everything, and thought, well, what if you don't? And what if we optimize for the case where you don't? Maybe that subset of the language will actually run really fast, and it did.
Okay, that's interesting. Okay, all right. So you worked on V8 for a while, and then kind of what was the next step, and how did you know that would be the next thing to work on?
Oh, worked on V8, optimized it through Crankshaft and all that stuff, and we threw in like so many hours, like countless hours, on making this robust, making it stable, implementing all the weird and exotic parts of JavaScript to write eval that can introduce like a new local variable that it can delete again, and just like crazy stuff like that. The ability to take a function that you found somewhere and say, tell me what argument someone provided to the last time you called this thing, if it's still actually executing on the active execution stack. Things like that were just hard to implement and get right. And it just, like, V8 just sort of kind of ballooned from there, like the core beautiful V8 that we loved to build initially, to that thing that could actually run everything on the web. And there's something I take a lot of pride in actually like making it through, making it still fast, even though we made it complete as well. But you could also tell that the core of it was simple, very robust, and everything sort of on the outskirts of that was much more difficult to keep robust, secure, all those things. So we just found that we had an interest in saying, what would happen if you actually found a way of disallowing everything that made JavaScript really expensive, difficult to implement efficiently, and just got a much smaller core, something that was really built to be the foundation for the future of web apps. Because people need robustness, they need performance, they need something that works in a mobile setting, it just needs something that's really, really good and simple. Because, I mean, the ideal, at least for me, is to try to build complexity on top of simplicity. I mean, if you think you do it the other way around, you try to build something so simple, or try to achieve a goal on top of something that's very complex, you sort of fight the system all the time, right? There are intricacies or difficulties just figuring out, like, how do I make my JavaScript code run fast? I think for a while that was a big challenge for people. They didn't know, like, can I use try catch, or is that slow? I don't remember. Maybe it's fast on Safari but slow. It was just difficult for people, right? So we thought, hey, what happens if we go back and say, let's ditch JavaScript. Let's allow people to write code, web applications, in a new language that has this sort of the core of what made V8 good, but have none of the problems. And that was Dart. So we really thought that by doing that, we could simplify the code base that everything else had to be built on top of, and make it much faster for us to push performance and robustness in that space. We had ideas about serviceability as well, so that with Dart in the mix, maybe we could make that sort of high-level changes of dynamic behavior more structured and better to understand, so people will start using that more. We just had ideas on how the web could go from being a great place for applications to being a truly awesome place. And it all, at least in our heads, right, revolved around this idea of giving it a more structured, a more useful language. So we came up with Dart, and we pitched that internally, and clearly there were other groups at Google that thought the same thing. They were building applications, and they struggled with JavaScript. Google had Google Web Toolkit, that had Closure Compiler, had some different options there for trying to make it more manageable to work with JavaScript at scale. But they're also looking at something that were more structured, allowed them to work comfortably on very large applications. So we thought, hey, that's a good match. So we teamed up with a couple of these teams and formed a fairly large Dart team to try to build a new language, like, for the web. And we really strongly believed that it was important to do two things well. built native support, like a virtual machine that really demonstrated that this could run really, really fast. At the same time, also allow this to be useful in other browsers, so we didn't get people to be stuck in, I've written this piece of code and it only runs in Chrome. We thought that was a bad thing for the web in general. So our like long-term like ideal would have been to get the other browser vendors to adopt Dart as a technology for the web and get them to be excited about this. I think the way we approached it and the way we ended up trying to convince them to do this, and clearly that was challenging to do, and I don't think we did a super good job on that. But we also, I think, learned through this that having like a healthy competition between the browser vendors and getting them all sort of excited about moving the web forward in some reasonable steps was challenging enough. Then coming in with something that looked like completely proprietary technology and throwing it into the mix and say, oh, by the way, we also want you guys to get this thing integrated into your browsers, that was just too much, I think. And at that same time, right, the whole squeeze on mobile happened. So offering a browser that came both with a JavaScript engine that like big and bulky V8 that was proven technology and a new thing was challenging, right? Because like, suddenly like, you would go from having a single implementation of a language in the browser to having two, and that just comes with a big cost. And at some point, I think we realized that that fight was just sort of not worth it, and people were probably better served with compiling Dart to JavaScript in context of browser. And we got some success through that. Like the whole Google Ads offering, what used to be called AdWords, it's a giant web app that is like a money-making part of Google, was rewritten in Dart, and the team there was pretty happy with that. So we found some limited success with that. But in some sense, right, we were always sort of interested in exploring the space where the Dart virtual machine technology could really shine. And we had a few areas. Server-side Dart was a thing. We had some interest in using it from the outside in that context as well. A few companies were very interested in using Dart instead of Node.js, and I think sort of we had some success there. But one of the things that's really nice about Google is that like they really want success to be not just sort of the bar is not like sort of reasonably high, it's very high. So I think for something to Dart to really have a chance at getting sort of a long life, it had to be in a place where it added a lot of value, right? So I think we were definitely looking for places where that could work out for us. We tried a few things. One is actually going more to the embedded side of things. I actually ran a project called Dartino, which was like a small version of Dart for. I love embedded devices, so I thought this is a great match. We saw some of the problems that we identified in our startup company were still present. We thought Dart, hey, structured enough, can actually fit here. Turned out the Dart libraries were a little bit big for this, so there were some trade-offs that were not super natural in this space. But what really made us like, stop investing in Dartino was the fact that something magical, almost magical, happened from the Chrome team, from a thing they called like Sky, which is the sort of the first version of what is today called Flutter. The team there came from Chrome. They came with this idea like there's so much stuff in Chrome. I mean, essentially the Dart idea, you could say, just for the browser. There's so much stuff in Chrome that people don't use to build beautiful web apps. What would happen if we just ripped that out and started over with the things that are really high value, the core things that just work really, really well, and build on that, and let people benefit from having a smaller base, right? Can we build something that's that then suddenly is small enough that it fits well on mobile and just is a great UI toolkit for those things? And for that to work out, they needed a language, and I think they found Dart there, and it just kind of worked for them, right? It's they stuck it in there, and it was like peanut butter and jelly, right? It's just some people really like that. I'm not a fan of the combination, but they claim it's a good combination, right? And this was definitely a good combination. So you got a really well-designed runtime system, a language, and a implementation of the virtual machine that really fit well together. And then you got on the other side of that a UI toolkit that was just well done for sort of custom UI work and graphically impressive web applications that were sort of joyful to use. So like the combination just sort of clicked right. And once we saw the first demos of it, I think we're just all sold then. And then I think focusing on too many things at one time, Datino and Dart for the web and Flutter was just something we felt like we can probably do a better job with Flutter for Flutter if we focus on that instead of also doing a little bit of embedded work. So we actually just made the call and said, I think we could spend our time more and better if we go to the Flutter side and try to figure out how can we make Dart even better for Flutter, and how can we make Flutter even better because of that. And then I think that this is where you started seeing us from the Dart team talking more about Flutter and engaging much more in that, because we just felt like there was so much we could learn from people that were using Dart in a new context, in a place where we hadn't seen it used before on mobile.
I'm so curious. Actually, a question came to my mind a while back, and I forgot to ask you, which was how much kind of internal talks or pushes is there when it comes to making changes to certain things, right? So I'm sure somebody in Google may have come up to you and said, we could really use this extra feature. I'd like to have that. Can you work on this? Versus if it came from the outside, somebody kind of making like GitHub making like an issue or appealing to you on a forum or something. And then after that, I'd like to follow up with kind of like, how did this whole entire discussion with, how did Sky get started? And how did they come back to you and say, we'd like to do something together? So sorry, I kind of gave you three different things, but these are three things in my head that I'd like to know about.
So yeah, on the language improvement front, I think when you work on languages, you get lots of feedback, and I think you learn to at least appreciate that any kind of feedback it's very subjective. So when you can get feedback that feels less subjective and more based on, actually, we've used this pattern in 10,000 places across the whole code base in Google, and we've learned that if you just did this instead, it would be much better. That has more weight, right? So I think it doesn't really matter if it's internal or external, but that sort of that volume, that quantification to it, where people can tell you that this matters because does change how you perceive it. I think we probably had more sort of discussions and areas of conflict on what to do with the language internally on the Dart team, right? Because we also cared so deeply about the language. And I think you find this in a lot of language teams, that, you have this mostly healthy, but also sometimes really unhealthy, like discussions about like where to go, what to do, what to follow, what are the principles. Like it's very difficult to do this well, because there's a lot of subjectivity to it. And then whenever you hear something from a customer or from a user, and there are two things you can do. You can bring it forward as a sort of an anecdotal evidence for something, or you can start using it as an argument for doing something. And I think we all have done some of that in the past, right? And it's meaningful, but it's also something you have to find a good balance for. It's a real challenge. And we certainly had our challenges in that. I think it became simpler when Flutter arrived. Suddenly, I think what we were optimizing for became smaller. I think we knew the web part very well. But suddenly we also had this mobile part where some of the features that you mentioned have been brought to the table recently. We could see that they could work out in Flutter, and we could even get feedback from the Flutter team and users of Flutter that this would make sense for them, right? So I think that's the balance there. It's less about internal versus external, but sometimes, yes, we just knew the people and trusted the people on the inside more, and that gave them sort of a larger voice. The other question you had was around how Flutter got off to a start, and I think Eric Seidel can probably tell you the story much better than I can, but I think it really was the same kind of sort of idea that when you work with like technology, sort of in context, at some point you might get you might feel that what you're spending most of your time on is not adding enough value, right? You spend all your time making sure that it still fits with everything else it has to fit with. And if you just had a way to cut off sort of all that fat, you could move so much faster and make the system so much better, so much more quickly. And I think that's the thought experiment they started with, right? That could we really move these things faster? How small could it be if we just like dropped all this? I think there's a hypothesis that you could make it so much smaller if they were willing to drop all these things. And I think that turned out to be right. So I think Google is well known for supporting this kind of innovative work, and once again, it's sort of they allowed a group of super great engineers there to try it out, and I think they hit on something, right? So hats off to them. I think that's sort of the birth of Flutter, you could say, right? I think it's very close to the story around Dart, right? We looked at this thing, we thought, what happens if we cut a lot of things out and start over on these things instead and put it together in a different way? So I think the mentality there is just like, don't settle for what it is today. Don't accept the status quo. Be willing to go outside that if you can prove that it adds enough value. And I think we were struggling with that there for a while, and I think that is certainly not struggling on that front anymore. Right? I think it's proven that it's actually super valuable to Flutter as a product, and to other parts of Google as well, where it's used in a web context.
Yeah, I definitely have to say so. I think to me, of course, I heard of Dart, and I kind of said, why do we need another language? At this time, I was using CoffeeScript quite a bit. I never really looked because compiles to JavaScript, okay, not a big deal. Of course, not until Flutter kind of came out, and it's like, no, this compiles to native, and also it also has the ability to hot code reload, with the VM and all this. It's like, okay, let me take a look at this. This is getting interesting now.
No, it is interesting, right? And notice that a lot of the things that are interesting in Flutter are not because of that, but a few things that really make Flutter exceptional are at least in part because of that, like the hot reloading support built by a few team members in the US, just enables something novel, right? We talked about this, and I think we've known about this technique for a while, but just making it so robust and so useful as it is in Flutter is just I think a great way of taking a good idea and actually making it useful in practice, right? It's something you can trust. It actually works, I think, compared to some of the other stateful refresh techniques that some other tools use. People tend to at least tell us that it often doesn't quite work, so they don't use it as much as they thought they would, right? For Flutter, I think most people actually use the hot reloading a lot. There are technical reasons why that works well too, because of the framework, because of this the functionally driven approach the framework has. It's part of the secret sauce here. But Dart's implementation of hot reload also really helps.
Yeah, actually, I'm kind of curious. Obviously, I can say, were you just kind of sitting down, kind of having a cup of coffee, talking to Lars, and all of a sudden Eric kind of sits next to you and says, "Take a look at what I'm working on," and what do you think? And by the way, I'm using Dart. What was kind of the conversation?
Yeah, pretty much. So I got dragged into some early conversations about how they could build this. Just because of our expertise in the JavaScript side of things, they were looking at different ways to everything for how to observe property changes like Angular style, or do the more functionally React style thing. We got dragged into that fairly early on, right? Just because I think we had a good take on performance considerations and all that. So I think we were used as a sounding board for some of their design discussions. And when we realized that they were able to use that in this context, initially I think we were a little bit skeptical. I wonder if this is gonna turn into something. And we're always busy with doing stuff for other users and customers and whatnot. But quickly, I think we realized that this really had potential. I think you know this feeling when you see something and it just clicks. When we saw the presentations of Sky that we showed off to an early Dart developer conference, it just clicked, right? This just makes sense. So yeah, I think that was it felt a little bit accidental, but I think lots of good things do. And I think once realized that what it was, it just felt very obvious to work very closely with the Flutter team on these things, and sit next to the team. And I mean, in many ways, the two teams were trying to optimize for just getting ideas to cross between the two sides, the language, the runtime, and the UI side of things.
I think it's kind of interesting that both actually Flutter basically came from Chrome, right? You guys kind of were brought in for this, and Dart came out of it, and then the Sky team kind of came out with this. I'm kind of curious, when you went to when you went to show off this, it was still called Sky at the time, right? You went to show it off to people. Was it still web focused? What was the changing time where you guys were like, wait a minute, let's try and let's kind of park web and let's go back to, or let's try mobile, right? Like what happened over here?
I think the realization from the Flutter team, right, was really that that mobile was sort of an unsolved challenge. Like cross-platform mobile, doing that extremely well felt like something that would have high value for Google offerings, but also on the outside. Right? We just saw a skepticism that people had, that they wanted it, but they also knew that it probably came with trade-offs they didn't like. But here we saw that we could probably build something that had the right cross-platform properties with very few of the bad trade-offs, right? So you can really get something that felt fluid, slick, native, nice, and still get something that actually works across iOS and Android. Um, Somehow the selling points were just so obvious that it just felt like, yes, people will react well to this if we can deliver on the performance and the smoothness and the developer experience.
That's like the funny thing is like I can imagine going to web, but to me I could as being somebody who I did do some native apps and of course I've done web for a long time. I just cannot imagine how you can go from web to native. Like, is it a difficult process? It seems like to you that it was, oh no, of course it's very easy. You just got to do this, and it's done. Like, is it really so simple? Like, or was it this? Because I heard that Skia engine, right? The SKI is kind of like brought a lot of this capabilities. No, is that kind of
Yeah,
the secret sauce too?
sure. Skia was like a graphics library used by Chrome and used by Android. So like a hardware accelerated graphics library. And I think so if you wanted to do something like a boiled down browsery kind of thing that you could tweak into the greatest mobile toolkit, you had to bring hardware accelerated graphics with you, and we just had a great library for that, Skia. So again, like the the Flutter team there, I think they found, I think Eric would probably refer to them like nuggets of gold, like hidden in this big thing, and just drag them out, like Skia, Dart, some of the layout systems in the browser, and then brought them together and got rid of everything else, right, and then built around that instead. So yeah, definitely there were technology achievements that they could build on top of that weren't there like 10 years earlier. So it's also like great timing, and sort of it's not accidental, right? It's I mean, someone realized that like there's so much more here that actually is really high quality. If we just put this together, we have something awesome.
It almost seems like you guys cracked open Chrome, started picking out pieces that you guys thought were really useful, and then went to the back room and pulled out some more things that were a little bit kind of maybe put on the shelf and dusted them off and put it together. It's
Yeah, exactly. Like suddenly things
yeah.
changed, context changed. Suddenly a few of the great ideas that we had lying around, like a virtual machine for Dart, just fit right in. Okay, let's do it. So that was great. Yeah. I guess the downside in all this, right? I really loved working on Dartino embedded devices and all that stuff. And like with this focus on Flutter, that just like didn't really feel like a natural thing to spend all our time on. But the notion of improving like code for devices for embedded systems was still like a big thing for me, and for Lars as well. Right? We started doing that at Sun Microsystems on small cell phones, and spent some years at our own startup doing this as well. And somehow I don't think we ever felt like we reached the right state with that. We didn't really like hit it to get to the finish line with really improving how people develop for like small like chips like these, right? Where you have like $2 microcontrollers that are probably like significantly faster than the first desktop machine that I used, right? It's kind of crazy what you can get your hands on today. So actually, after working on Flutter and Dart and working for Google for more than a decade, we actually decided that in sort of early 18 that we would escape from the chocolate factory and start something new in, I guess no surprise, in the language developer tooling space. But again, you could say centered around the idea of improving how people develop high quality functionality software for devices. So that's actually what I'm doing today. So my goal is super simple now. I have this entire row of CPUs here, and I mean, if you wonder why there's a CPU shortage, like a chip shortage, right now, I'm probably to blame. I have them all here in my office. So if you need some, let me know. No, I really love these chips you can get your hands on, right? You can get them, they're cheap and they're really powerful. So the biggest problem that I see, and what Lars and I saw when we started our new company, Toit, in early 18, was really this need for making high-level developers, people that know how to build web apps and work with like Python and server-side setting, comfortable developing functionality for like the IoT, for the Internet of Things, for devices. And so we actually been working for the last like well over 3 years on this project of making it possible for you to write high level code for a device that on a small microcontroller actually gives you like process isolation, just like Chrome tabs are isolated from each other. It gives you a way to run functionality code separated from each other through our virtual machine abstraction that runs on the device, and gives you a fantastic way of developing these small applications that can be installed, uninstalled, work with, even when the device has been deployed, is out in production, right? So we have customers that have small embedded devices that are sitting in the middle of the North Sea that are then serviced over a cellular connection. And because of the platform that we put on these, like the language and the virtual machine, and we call the language Toit as well, because of that, it's now possible to actually service these devices and upgrade them and keep them running like over the years. So in some ways, the idea of improving what you can do on small devices just never escaped us. And after being like in an American company for a few decades, it felt like it was time to try the startup scene again. So we're super excited about what we've managed to build there with a team of like Googlers and folks from Uber. And you're probably wondering why the hell is it called Toit? At least most people don't really understand why that name is, and it's an old joke, and it's probably a bad one as well. But Lars and I, we've always shared a lot of technical ideas, and then had lots of agreements and disagreements in that space. But one of the things we always agreed on was that the fact that one of the funniest movies ever made was a really silly one called Austin Powers. I don't know if you know Austin Powers, but the last one, the Goldmember one. Goldmember is this supervillain from Holland, from the Netherlands, who has a weird accent, and at some point he calls Austin Powers' father. He tells him that he's toit like a tiger, and it's a compliment. It means that he's really well built, tight. So we just thought that name Toit like a tiger was just a super meaningful thing. And if you want something in a software platform for embedded devices, it is that it's tight, it's closely knit, it's done well for that purpose. It's really Toit like a tiger. So we picked that name, even though it's kind of a weird thing to put in there, and it means something else in French. But I think it's honestly quite an interesting sort of piece of technology that we've built there for folks that want to try to build software, not firmware, for devices, and take some of their sort of high level skills and bring them out to the cellular connected, battery operated Internet of Things world.
So how does the whole thing work? Because I've worked a little bit with Nerves. I don't know if I've probably heard of Nerves because you're in that space, right? They have a A/B partition. I'm guessing you must be doing something similar because these things can fail, right? You have a cellular connection that could drop like that, especially in the middle of the Atlantic, right? So how does the whole thing work?
Yeah, so I mean, it's done at two levels, right? So at the core of it, on this small ESP32, a sort of a fairly disruptive chip choice from a Chinese manufacturer. It's a really excellent chip. It like a dual core, 240 megahertz RISC CPU. You can get that for less than $2, and it has like Wi-Fi and Bluetooth built in. It's pretty awesome. But on a chip like that, at the core of it, you have like a real-time operating system, and we put our virtual machine on top of that, and then all the way up, including the virtual machine, we consider that the firmware of the device. And when we update that, we do what you described. Like you have like a multi-partition setup where you build up the new version in the partition you're not running, so that you only flip over to it once you've made sure that that you've gotten all the way through the update. Right. This is like how Chrome OS works as well, with like the update mechanisms. You You're updating the copy that you're not running, so you can verify that it actually got the right update before you flip over to it in a sort of a sort of transactional style thing. So that's what we do as well. But for the applications that run on top of this, we just realized that we can actually allow you to install these applications without updating the firmware. So you can install new self-contained small applications and replace them as you go. And there, like we don't really need partitions. We just put these applications in Flash and find them sort of almost like in a file system. And so if you're installing version n+1 next to version n, we just allow you to say, I only want to flip over and use the newest version when I'm done with that install. And it doesn't have to be partitioned that way. So it's much more flexible. And this works because the applications are fully relocatable, so they can be stored anywhere in Flash. So we don't need to know where they end up. So we just move them and where it makes sense. And they're very small. So we can send like a new application to a fleet of 1,000 devices and just send like 30 kilobytes of optimized code to these devices. So we're sort of back in the object-oriented virtual machine world again here with building sort of a layer that sits on all these devices that turns these devices into, I would say, like small little serviceable, upgradable computers, right? Instead of being sort of hardwired microcontrollers that are difficult to interact with. And with that, what we built as a sort of a product is really a cloud-hosted API, a place where you, using gRPC, Google's RPC mechanism, you can go and interact with our APIs and through that communicate and deploy code to all your devices, right? So you talk to an API, sort of high-level, well-structured, declarative API, and through that you get to control your entire fleet of devices to the extent that you can even like push code to it, and schedule jobs on them, and tell it what to do over time, and get the data back from them. So it's like a very high-level IoT platform play, if you will, on the software side. It's pretty awesome.
So I was going to say, like, what is actually like when you say an application, right? To me, I keep thinking about something visual. So what kind of applications are we talking about?
So most applications in this context are probably simpler than something visual, because like clearly if you have a device like this, like where would you put the UI? So it's more like you could say like a measurement instrument, a sophisticated sensor or something that gathers data. It could be from like reading the temperature, the humidity, the CO2 levels, or even decoding some images or video that you have on the device, and then making decisions based on that data, filtering it, aggregating it, and in most cases forwarding at least part of that data to the cloud for further analysis or for a better integration. So it could be a push button, like what's called Amazon Dash button, where you could order extra cereal by just clicking a button that was hidden in your cupboard. You could definitely build something like that where it doesn't have a UI, but it does have an actionable thing, a button. Or you could piece together this like sea monitoring device that I talked about, where you can install a device out in the sea that measures like water quality and things like that, and report that back in a meaningful way, or control some process through it, either like opening or closing gates or dealing with things out there, right? So we see people doing a lot of sort of fairly innovative work in the sort of the agri-tech space, where like indoor farming is really exploding. Like these different ways of like vertical and indoor farming and doing intelligent, smart farming better. It's become a very hot topic, right? And there, like you need to control ventilation and supply of nutrients and other things based on the kind of readings you get from these devices. So even though they don't have a UI, they still may not interact so much with you as they do with their environment. Does that make sense as a sort of distinction?
Yeah, definitely. I understand now because I was just thinking about how you can actually read the data. So if it is reading information, it's just probably sending data back, and then you just have to read from that source that's collecting all the information, right?
Exactly right. So we see a lot of customers that actually end up like wanting to do interesting things with the data on the device, right? I think the old school version is forwarding everything to the cloud side and making decisions there, but there are just like latencies involved. You have to send the data over a cellular connection. It just doesn't feel quite right for all of it, right? So we actually find that most sophisticated users end up doing at least a chunk of the work on the devices because they're so powerful. You can do so many things on the devices. Like these edge computing devices are very powerful, even though they cost less than $2, right? So harnessing that and making better decisions out there while the device is on your kitchen wall, so it doesn't have to communicate with the cloud to work, is actually a real strength. I know like cellular coverage is getting better and better, but I think like when you're in the physical world, it still feels like you will have outages. You will get into areas where things are not working as smoothly, and there it's really nice that the device is capable of making decisions sort of in a more asynchronous way, and in a way that's decoupled from the cloud in a healthy way.
So how does that work? Like, I can imagine, I mean, I have so many questions in my head I'm just thinking about because, I mean, I'm aware of, I mean, working on mobile apps, right? You lose connection all the time. Network partitions just happen. So, I mean, do you like queue things up and then try to send them out again later and you kind of abstract that away from the user when they write their app? I mean, how much of the stuff is the app writer versus how much do you guys handle and how does this whole thing work?
We found, and it's sort of interesting, we started with that, let the app writer deal with it. It's probably the easiest, but it turns out that most of the decisions you make from a single app are not ideal for the system as a whole. So a device like this, to preserve power, to preserve like battery and run for a long time, they want to go to sleep and enter like a deep sleep mode, like hibernate, like your laptop might do, right, to preserve power. And when they do that, you need to shut down all activity on the device. So you need to schedule that really, really well. So moving the scheduling decisions and like the logic a little bit away from the applications and make the system take care of more of that is a logical way of achieving that. And that also applies to the data side. So if you want to send data or produce data, it's probably a better way of saying it, then you may not actually want to also dictate when it's a good time to connect to the cloud in terms of preserving battery. And so it might be clever to like bundle things up and send things in some chunks. It might be good to wait for that other application to be done generating the data that it wants to generate. So you really need the system to take care of that for you. It's a really long way of saying we take care of that for you. The application cares about producing the data, and then the system takes care of connecting often enough to offload the data when that makes sense. So it's really about sort of an optimization challenge in a sense, right? Make sure that you get enough responsiveness, but still also preserve enough battery to make this work well. And we found that the best way of doing this is really helping the developers and let them sort of declare what they need from this. They tell the system, not that I want to write a piece of code that says I write the loop that connects every 3 days, but more like say declare in a configuration file that this application needs to run at least every 3 days or when this kind of thing happens, and set that system up. And I think if you're familiar with like microservice architectures in a cloud setting, this kind of idea of having sort of rules and configuration between the services is a fairly common way of setting these things up, right? Because you want to reason about those rules. And if it's all code, sort of imperative that does something every now and then, it's very hard to reason about that collection of code. So we went for the declarative configured way. So all applications tell you what they intend and what they need, and then the system optimizes for that. And it's hard to explain. You probably have to try it out.
Yeah. I mean, if there's a way I could try it out, I would love to try it out.
There is a way. So we just opened up the ability to actually run this the system on your devices. So if you have an ESP32 device, or if you know how to get one, it's not expensive. It's very straightforward to go to Toit, Toit.io and sign up and just provision the device and get it to your fleet and start coding on it. In there, you can also get a glimpse for what we think might be the best choice for a language for the connected devices out there. We have some language tutorials, and I think there are lots of people that care about language. I know I do. So I think if you're into languages and want to get a sense for how a freshly designed language for that context could look like, I think we have a pretty good story around that in the documentation side of things.
Okay, I have to take a look at this. I just saw a block of code. I was surprised. I saw white space.
You saw, yeah.
Yeah.
we've come full circle, right? We've looked a lot about these different things, and there's something appealing about being white space significant white space in some contexts. We feel like this is actually one of the areas where it could work. So we've actually pushed on that for this. What it really enables for us is a super lightweight support for user-defined control flow and control structures. That means that like an if statement in the code, which is sort of a built-in thing in most languages, you can write your own control structures that look exactly like that in our Toit language. And there, not having to add parentheses and braces around the function expressions or the closure you pass around really helps make it all sort of fit together. You know, there's a difference between like for each in calling for each on a collection in Dart or on JavaScript, or using the built-in for loops. It just looks slightly different, and we wanted to see if we could remove that difference and promote the use of user-defined library-provided control flow structures instead. And I think it actually works really, really well. And the implementation of these closures, these blocks we call them, is really slick. So it's, I think if you're a language interested developers, you probably find that way we've done that quite intriguing.
Now, do you also have the idea of isolates? Because I mean, it's two cores, right? So I guess you must have some kind of scheduling underneath, right?
I'm happy you asked. Yeah, so we do. We decided to call them process instead of isolate, but they really are like independently scheduled entities that run in their own memory space. We allow them to communicate, and essentially, in this context, there is nothing but the Toit virtual machine. So every application that runs just runs in an isolate, in a process of its own, and the virtual machine provides that. If you were running on top of something like Linux on a sort of a bigger machine, Linux would give you processes. But here, like you're on a microcontroller that doesn't have support for that. There's no hardware support for memory isolation. So we had to build that in software. We're happy to, but it gives you that ability, right, to build functionality around the idea of having multiple independent units that can fail independently as well. So there's a lot of sort of Erlang inspiration in this as well, and the ability to actually start new processes from within one process and have that do something for you using the multi-core properties of this underlying system, but also getting things like garbage collection is suddenly now a thing for a specific isolate. So if you have a lot of memory churn in one isolate, it doesn't cost for the others, right? If you didn't have isolates and you did lots of allocation, it would hurt the entire system. Here it's much more, well, no pun intended, it's much more isolated, right? Also in terms of that. So yes, they're definitely independently executing sort of units there. We call them process, but they're really isolates.
Yeah, I was actually kind of curious because I think I did ask you when we first talked a while back about like where did you get the idea from? Is actually you looked at Erlang and said this is interesting, or was it something
Yeah,
else?
yeah, Erlang was a pretty big inspiration there. I think like the Erlang guys were more relentless in the pursuit of using this as the basis for all programs, and they probably got some better results because of that. I mean, they went all out on this. So a well-functioning Erlang program is like nothing but a collection of processes that communicate in ways, right? So they went all the way, and maybe we should go further with it. But I really think that this notion of running things in isolation and being able to reason about them on a more separate level is just a very useful way of thinking about solving problems. And there's something really interesting about this sort of like some of the Erlang concepts with like failing fast by saying, well, we don't try to solve a problem within one process. Let that fail and deal with that at a higher level, because you're probably not going to be able to recover that state in there anyway. So don't try to do that in the common case, right? Because you have building blocks that can like fail at the right granularity instead, the processes. And so we try to replicate some of that. Clearly, we're a little bit constrained here. We run in like 0.5 MB of RAM, so you're probably not going to be having fun spinning up 1,000 isolates. But we definitely see people running with a number of them, and they like that they can separate critical functionality from less critical functionality as they test these things. Right, they have things that they'd rather not change because it's core and critical for them, like the update mechanism that we run sort of in the kernel of the system, if you will. that's isolated using the same mechanism. And that allows us to guarantee that you can always service and update the device, even if you have an application that's doing a busy loop.
But then you cannot do hot code upgrades, right? You have to always flip over. Or
We do
can
the
if you do a hot code upgrade?
No, we decided to do the flip over instead. The isolates are generally smaller here than the full state of a Flutter app. We thought about doing like hot reload for that instead and preserve the state. We find though that applications on these devices are a little different because you generally don't have long running applications on these IoT devices. That the device goes to sleep fairly frequently, and that means that you sort of have to get used to writing code in a almost stateless system, right? That you boot up, like RAM is cleared, you start over, you build up some state, you capture what's important to you, you store that somewhere, and then you go to sleep again. And that's sort of more the model of it, right? So telling people that you can run forever and then we can change the code while we keep the state, at least we've found so far that that's not a really helpful thing for the developers that also need to consider the fact that the device is probably going to sleep within like the next 3 seconds to preserve battery. So it's just a different setup, right? A mobile app runs for a long time compared to an IoT app that boots up, reads something, records it, and shuts down again.
What kind of like I'm kind of curious about because I can imagine if you put like a sensor into something that you had to know if there was too much or too little of some type of measurement, right? How often are these things running for? Are they running for like just a couple times a minute, or what's kind of the running frequency?
It very much depends. And we've had some cases where people wanted to run like for multiple years on sort of completely standard AA batteries. And they're often like you boot up maybe every minute, measure something really simple and go back to sleep. If there are things that are more expensive to measure, like say getting a GPS location from scratch without any help from other systems, it takes longer, right? Then you probably want to do it less frequently. So generally, what people end up doing is adding it's like fairly sophisticated functionality on the devices to deal with the differences, so that they optimize the battery usage. So for instance, they don't go for a static pattern of every single application will run every 5 minutes. It's like this part of the application, this job, this task will run very frequently but do very little. This other part will happen only when we see this thing happening or when told to. And they sort of they spend a lot of time on the scheduling and understanding how often they have to force the device to run because this is really where it spends its energy. So it's very hard to say as a rule of thumb, but we do see people that are measuring every second, and that works beautifully well, as long as they're not measuring like too much and trying to store it in a too small flash, right? So it's all like how fast do you have a connection to the internet? Do you have like narrowband IoT or Cat M1, or like what's the bandwidth? So it's a little bit more tailored to the situations the devices end up in. I think you're muted, Alan.
Yeah, you caught me. No, I mean, I'm kind of curious. Like your whole, I believe, just your product. I mean, you're not really focusing necessarily on the hardware itself. You're more focusing on orchestrating the updates and this kind of stuff, right? You're not really doing the designing devices for people. Is that
No.
correct?
We're a software platform, but it is something that covers developer tools on your workstation. It covers cloud infrastructure that takes care of all the hard parts of orchestrating software rollout to a fleet of devices, and then device software that makes the device a robust target and a performant target for your applications, right? So it's like a three parts to it. So it's a very horizontal offering in that sense. But no, what our customers, they actually come to us, right? And they carry a roll of chips like this. This is the ESP32s. And then they put that together and design that they want. You can buy off-the-shelf designs too if you just want to play with the developer boards and things like that. But they come with the hardware, put our software platform onto it, and suddenly they have a machine that they can really work with, even if they're more used to working in a web context or writing Python for a server.
So what I would call the end client or end user of your system, right? sorry, let's say the developer themselves, they're actually coming from a web background. I heard you mention that before. They're not really coming from a embedded system background, right? That's who you're kind of targeting.
Yeah, we see that. I mean, I think we're super attractive for people in the embedded space as well. But I think where we really enable new people to play along, developers that may not be experts in low level C code to actually do something on a device. I think that's really where we see us standing out from the crowd, right? We have lots of people coming to us that are used to writing or toying with or dealing with IoT based on, say, Raspberry Pi. And the Raspberry Pi is a beautiful little machine, right? But it's like a single board computer that's running Linux that has like too much memory and it has like everything, right? So people write small snippets of Python on that reads temperatures and forwards that to the cloud. You can do all of that and do it better on a device like ours that's significantly cheaper. It works really, really well on batteries. That's very hard to do with a Raspberry Pi. And we get to upgrade the entire software stack with updates that are less than 100K. Even like the full firmware patches that we send over can be very, very small because the system is just Toit. And with that, we can service such a device extremely well over like a SIM card based communication channel. And that's just very hard to do with anything in the Raspberry Pi class thing, because sending over like a 10 megabyte update or a 100 megabyte update for getting like the new Linux kernel and everything else updated here and like a Python version update, it's just painful. And then you have to deal with maintaining all this stuff yourself, or you have to use another layer of like system for that, and the complexity just adds on, right? We just cut all that away and say, if you want to read peripherals and measurements and sensors and interact with that and still be serviceable from the outside over a network connection, we have an option for you, right? It doesn't solve all needs in the world. There are things a Raspberry Pi can do that an ESP32 cannot in terms of compute power. But if you really care about reading like a CAN bus or a temperature sensor or sort of engaging in that part of the world and building functionality around that, like why don't you pick something that's like orders of magnitude better for that, right? In terms of the hardware, and put a software platform on it that allows you to still see the world as like a high level thing where you get to decide what code to run and when to run it on.
Okay, that's pretty cool. I was just wondering. Actually, kind of lost my train of thought now. I took my first dose of the BioNTech vaccine earlier today, so I think it's starting to work on me.
Oh, congratulations.
Yeah. Let's see if hopefully I can make it to the second one. I did have a quick question about something, and now I lost the train. Actually, sorry. Now I know the question now. The question I wanted to ask is, what's like the most crazy or interesting thing that people are actually doing with the Toit platform right now?
Most crazy or interesting thing. I think the most crazy thing that we're seeing people using Toit for is really when they're in sort of a disruptive field like autonomous vehicles or controlling a sophisticated biological process. When they come from that and they're in a complex, difficult environment, and they think about how do we monitor and measure and work with that from a small computer that we can add to it. That's where we fit in, and that's where we see ourselves being sort of glued onto or attached to something that is, even in its own right, really, really crazy, right? So like autonomous vehicles, they need to be tracked over time. Like telematics for that is definitely like a hot topic, right? And when we see people coming to us to get us to sort of help them get like best in class telematics for that space, it is kind of crazy, right? I have a colleague here who's building like a full-blown drone based on Toit as well, controlling all the motors and all the rotors and everything else. And we're starting to see interest in that kind of thing, right? Because it's a complex thing with gyros and stabilizers and making all that work. And it's all software today, right? And I think we just really fit well in that. So I think honestly, maybe the craziest thing I've seen so far is a guy running scared around in his living room because the drone that he wrote the code for is getting out of control. Like that is kind of crazy and scary, but it's also fun.
So did he live stream himself to you to see that, or are you actually in his house when this is going on?
We went there. We had a small outing, and we went there, and suddenly he wanted to demonstrate it, and it was like you could just tell the excitement around this thing with motors and rotors and everything that that you have to be a little bit careful with these things. But it's and it was inside his house as well, so I guess he also cared about his furniture. But those are kind of crazy things that we see, right? Often people start with something relatively straightforward. They want to monitor and measure something, and they want to get the data out, and they want it to be completely reliable. So they come to us because they need to trust someone to deliver the foundation for just getting this very critical data from like the setting they're in and out. But I think once they have that, some of these ideas just pop up and people start doing like crazy things with it, right? He posted a video on, I think on Reddit with part of it where he's showing like one of the stabilizers on a small Lego man and how it sort of all works, and it's like a 30-second thing. And I think a few people got excited about that in the ESP32 Reddit community. It's just fun little things, right? So crazy and hardware sort of in this space, it's not a common combination. So I think anything we see there where people are pushing the envelope and doing crazy things is a healthy sign that people are starting to toy, experiment, innovate. And before something like Toit was a possibility, people would just be extremely conservative on anything that they put on these devices because they didn't feel like getting in trouble if they bricked the device and never could reach it again. They just didn't want to try things out. So, I mean, another crazy thing that we see people do is just be completely sure that updating the firmware on all the devices that are in the middle of the sea is just going to work because we take care of that. In some sense, that feels like, at least to them, like crazy if they look back at what they did before, right? We have companies where the entire company would like hold their collective breaths when they send out the half-year update because like they tested it and they were quite sure that it worked, but if it didn't, they were in trouble, right? And so for them, it probably feels crazy that now they can push new code every week, just like the rest of us do in a web setting or in a mobile setting, right? It's like welcome to the modern world.
Is that kind of what you feel like when you bring this technology to these people? It's just like, hey, you're finally in the same decade as us. It's good, right?
Well, that's exactly it. And I mean, some of them may not like that, right? I guess if you're really, really great with a C compiler and embedded systems, there's still a strong need for your skills. But I think it is nice that it opens up this as a playground for all of us that also just want to write stuff and play with it, try it out, right? Without feeling that it's a scary thing to push new code to a device, right? So yeah, like lots of things have changed, and the embedded world needs to change too. I think follow the modern trends. Yeah.
So I can imagine like you're just in like a big control room, just like Apollo 11, right? Everybody's kind of holding their breath, and is that what it's like when you have a new customer and it's your first time deploying, and they're
I think
cheers and everything.
Oh, and people get excited, right? And I think as long, I mean, that's part of our mission, right? It's just showing that they're not the first ones to try this out, so they can feel assured that we probably that we are set up to be like someone they can rely on to do this for them, right? I think most people today trust that the Linux kernel will behave, and we're sort of at the same level, right? That we provide that functionality, and chances are that you will not run into a bug in the Linux kernel. You might, but it's rare, right? Because it's just so heavily tested and so heavily used. And I said we're in the same space, right? We take care of this critical piece of the functionality because we're really good at that. And we have a great team that have built this for browsers, for mobile, for other settings, for like the majority of the team that works on the cloud infrastructure we have used to do cloud infrastructure at Uber at scale before, right? So it's sort of a dream team for solving this problem. I would say that for me at least, it's a nice sort of continuation of sort of work that I really care about, but still in a new context. In this time, startup company, where we really feel that we're onto something here that can, I think, change a good chunk of how the industry and the area around connected devices, how they develop functionality, how they work.
So was this again Lars that kind of said it's time to leave, and this is what I'm thinking about?
I would say that this time around we sort of talked about it we've talked about this for years now. That I mean, at some point we should do a startup company, and I think Lars again left Google before I did because I think he felt like it's never going to happen if I don't if I don't start. And that's all his thing. He's a great starter there. And so he did leave before me. And then at some point I felt like, okay, maybe this time, maybe it's right. So I left as well. And then we got together there early 18 and really started hacking on this thing together. And we actually started working on the Toit language, the Toit implementation, in exactly the same building, part of Lars's old farmhouse, where we started the startup company that we ended up selling to the Swiss company, where we wrote the first lines of code for V8. And then we returned later here for the next startup company as well. So when Google hired us in, we actually got back to Lars's farm. When we started Toit again, it was also back to the same place. So that's been the starting point for at least 3 things that we feel super proud about.
That must be a very expensive piece of property now, that if so many good ideas get started in this place.
Sold it. So so it's like the next idea will not start there. So that's the way it goes, I guess.
Or you're not going to come back to them and just knock on the door and say, "Excuse me, can I hang out here for a couple of years?"
Well, maybe that's a good idea. Maybe that's the right approach. I have another idea. I need to borrow your farmhouse. Yeah, that could work.
I just keep thinking about your background, right? It's. I know people kind of stay in the same industry or whatever, but it seems like you bounce back and forth, but between the same, I would say, 2 or 3 areas, at least 3 to 4 maybe. Kind of embedded, trying to solve, mostly embedded stuff, right? JavaScript, you kind of bounce around in between. Java, no relation, obviously. It's just interesting how you kind of stayed in this space.
I think like virtual machines, language, developer tooling. I think that those are the core things. They have different flavors, right? Targets can be browsers, mobile, embedded. Language can be like Java, JavaScript, Smalltalk, Toit, maybe one day Erlang, right? But I think at the core of it, that sort of that mindset, that find a target where you could really help something move faster, and use something that you think you're good at in that context, and figure out what's the right things to bring along in terms of languages, runtimes, and people, and then go do it. I think that's been sort of my take on this for now a couple of decades.
Yeah, that's great. I think this is probably a great spot for us to kind of wrap up, right? Because you're at a place. I mean, you talked about a lot. We've been here for about 2 hours and 15 minutes, right?
I know.
I want to keep going, but at the same time, I need to also get some rest, and I think
Makes
you need
sense.
to also rest your voice.
Yeah, I know.
So,
Talk too much.
is there? As I say, is there anything else you wanted to say before we start to kind of wrap up with a couple of things?
No, I think maybe it might be worth repeating that. I think it really is healthy that the world has gone sort of multilingual. That people and in the programming side of things are happy trying out things like playing with Rust, building with Go, writing Java, JavaScript, C#, Dart. I think it really gives more flavor to what we do, and I think it's very healthy to feel comfortable in many different languages, because I think it makes you a better programmer. In particular, if there are languages that have different properties, right? That you learn something different from each of them. I think I mean maybe that's a good parting thought from my side, at least, that I feel fortunate that the world is heading in that direction, and that the appetite for innovative languages and ways to express programming thoughts seems to be going like the right direction, and I think that makes it even more fun for people like me to implement these things and then put them out there and get some feedback and some traction.
Yeah, that's true. I find, the more languages I learn, the more better of a programmer I become. You take some pieces from over there and you connect them together.
Yeah.
But the one thing that does bother me sometimes is like when people use camel case in Python, right? It's not the right style to me. To me, that part really ticks me off.
Yeah.
Or do you have any kind of thing that really bothers you about when people write certain languages?
Indentation by tabs. Yeah.
I was going to ask you about it. Are you a tabs or spaces kind of person? But I was afraid that maybe you would get haters either way.
Yeah, I probably will, but that's okay. Yeah. Or too much indentation, like 8 spaces or something. That's just crazy. Yeah, too much. Yeah.
I've never heard of 8 spaces. That sounds ludicrous. I think 2 to 3 is already enough. Once you get, with Python, right? Once what is it? 72 characters? Is that the width? I think.
Maybe it is. Yeah.
So,
Yeah.
So then you must have a style guide similar to that if you're going to be so close to Python, right? You also have a 72 character length or anything like that for the Toit language?
Yeah, we do have some sort of implicit style guides in a few places and a few more explicit parts too. But I think honestly, a lot of style guides are today being replaced by automatic formatting instead, and that is probably a healthy thing for a lot of developers at least. It's not everyone's cup of tea, but I think it probably solves more problems than it introduces. So I think that's probably a healthy thing, right? Don't spend your time on that and just blame the tool instead, and that's probably fine.
Actually, I do have one last question. Now that you're kind of bringing in some more stuff with me, as somebody who's kind of created now, it seems at least two languages that I can think of, right? The Toyot and Dart. There's probably more. What do you think is kind of, the top 1 to 3 things that really make or break a language? To me, I think I heard a lot of this is probably about tooling, right? If you don't have proper tooling or a build mechanism, that's probably really kill a language.
I think I'd love the answer to be different. I think I'm not really sure. No, I think honestly, I think the answer is that it has a meaningful context. Like it has a vehicle to attach itself to that, where sort of where in the context of that it makes a difference. So like a language without a use case, a place where it fits in, something to attach it to, is almost not interesting, right? So a language of its own doesn't make a ton of sense, I think. But a language in a context of a browser or on mobile, like Flutter or Toit in the IoT space, I think that makes sense in that context. So general purpose languages are just kind of hard to get out there as that. They need to usually get out there through success of something else, right? And I think we've seen that in the past too. Objective C was the Apple push for that. A lot of things like that, right, has happened in the past. So I think for the outside of that works. On the inside, I'd love to think that simple, well-designed, consistent languages make it all the way through. But in practice, I think there's a really large appetite for also large languages, sort of in the mainstream community. So I think being too hung up over having the smallest, most elegant, well-designed language is not necessarily a recipe for sort of large-scale mainstream success. I mean, you can end up with a much better language through that and maybe get like a diehard sort of group of people that really like it. And I think that's really, really a good idea. But if you really want to make it big and get 1 million developers, there probably will be some feature creep where you try to cater to different programming styles and different things, right, just to make it out right. So it's probably much more pragmatic than sort of a idealized when it comes to language design if you want to make it big in terms of like developer eyeballs. I think that those are the main two things. And there are lots of small details on how you can do things you should do, but I think those two actually are more important than anything else, right?
Okay, that makes sense. Yeah, is there anything else before?
I think that's it. I think we set out to have a conversation here of. Did we agree at least an hour? I think we did that. So thank you so much for your time, Alan.
More than double. All right. There's a couple of questions I wanted to ask you that we always try to ask people whenever they come on.
Okay.
The first question is, when you do write Flutter apps, right? What kind of state management solution do you usually use?
So I don't write a lot of Flutter apps, so maybe I'm the wrong guy to ask about this.
Yeah.
So I know that it's a big topic, and it's really nice that you have lots of opportunities, you have lots of like libraries that pop up. In some sense, I think it's a major strength that something as important as state management is something where people can try different alternatives out. So the fact that you can ask that question, I think that's a good thing. If that had been built too much into the system, we wouldn't have seen a couple of options like pop up and have that discussion, right? So even though I'm not a user of it, I like that you can even ask the question. Have you ever had that answer before?
It's the most non-answer yet answer I've heard ever.
Great.
So I wasn't expecting you to have an answer, but I am interested to hear what you have to say. There's also a follow-up question, which is why do you think there is so many, like, why is it such a hot topic? Why is there so many different things? Like, why can't the team just decide on that? This is what we're going to use, right?
It is hard.
Is this something, is that just what it is? It's just hard?
It is just difficult, right? I mean, object orientation and all the ideas around that is a lot about dealing with state, right? Without any state, a lot of things would just be simpler. But I think most of us live in worlds and parts of the world that are stateful in some form. So we need to deal with it somehow, right? And then it's all trade-offs, right? If you optimize for one thing, you make certain kinds of reasoning easier to do with one mechanism. You make certain other kinds of operations harder, and it's just kind of it depends on what you want to do with it, right? So I think there's been no great solution to this. I mean, the most extreme one is like the fully functional programming style, which tries to come around the problem in a different way. But I think for most cases where you feel like you want to operate with statefulness, you have issues, and there are different approaches to solving them. I mean, in some ways, it's beautiful on IoT here, where you get to sleep all the time, and it's like state goes away so often that probably becomes less of an issue by design, right? It also puts limits on what you can do. So.
I think the last question I have, I'm going to try to make this more general because I can see that you're more into other things than this.
I'm the engine
that's
room
totally
guy.
Fine.
Yeah.
That's totally fine. Like, do you have any kind of if somebody really wants to get out there and learn something and actually really get into it, like, do you have any kind of recommendations of how they can approach this?
I think some people really learn well by example, right? So I think starting with looking at things is a great thing. But the trick that always worked for me is not stopping at looking at code, but also working with code. So I think when you download that first Flutter example or look at that first snippet, don't just think about it. Like, get it down on your machine, make sure you can run it, set some breakpoints in it, step through it, like break it, change it, massage it, do whatever you want to it, but change and make it yours. I think a lot of people are trying to read like a book and then think, okay, now I think I know what Flutter is. I would recommend reading books, but I really think that it makes more sense to do that after you've just tried to hit it with a hammer. Like, don't be afraid of just getting your hands dirty, and use the debugger and like step through things. I think that's honestly for not all, but for most people, that gets you across that hurdle of I wonder if I can do this, and get you, yeah, of course I can do some things with this, and then I think it's time to start sort of ramping up on more complicated matters. But I think, yeah, get used to the tooling, the debugger, and then step through things, understand them by seeing how they actually work at, I would say, a relatively low level. Like, how does it actually work? I think if you're curious about that and you get some sense for that, you've come a really long way.
I think that totally makes sense. That's an interesting way to look at it. Yeah, break it is something I haven't heard anybody ever say on this podcast, but that's something I do hear outside of the Flutter communities. Break stuff and see how it all works.
It's sort of a hardware way of thinking too, right? That like disassemble it and put it together again, and it's probably broken when you try that. But I mean, with software, that's cheap, right? You can always just start over.
Yeah, you have Git, right? You can just reset everything back to the head.
Yeah, exactly. Git's your friend.
Yeah, thank you so much. I mean, I wish I had more things to ask you, but I'm running out of E over here, and I think yeah, it's taken too much of your time today. I really appreciate you coming aboard. We'd love to have you back if we have a good topic or whatever. If you have something new for Toit, I mean, I'm also interested.
Yeah, next time I will
definitely in the summer space.
Next time I will demonstrate that magical language for you guys.
I would love to see the drone fly around the room.
We should get a video, yeah.
It's you running from terror, yeah.
Sounds good.
Okay. Perfect. If there's nothing else from your side, then yeah, I'd love to have you back on, and have a good day.
Thank you so much, and enjoy your day as well.